Hello everyone and welcome everyone to our channel Schrodinger's Cat, and this is basically Devabrata here. So in our previous lecture we had discussed the matrix and determinants from class 12, and in the today's lecture we will discuss the complex number from class 11, and we will cover the chapters the algebraic operation, conjugate, modulus and argument of amplitude of complex number, square root, cube root of unity, de Moivre's theorem and the nth root of unity, rotational theorem and use of complex number in geometry. And the total number of questions are coming in the JEE Main in this topic, from this topic, that basically the 2 or 3 questions are coming, and JEE Advanced 2 questions are coming from this chapter. And for one important thing is that for your exam point of view, we just here today discuss the chapter summary in a nutshell and do problem the JEE Main and Advanced previous year question, and after covering all the topics we just switch our lecture and the theory discussion sessions. So let's get started. So first of all, in complex number, that here in the complex number chapter, that the imaginary number I is equal to root of -1, and suppose a plus ib, and here that the a is a real part and ib is the imaginary part. Conjugate complex number, that if z equal to x plus iy, then the conjugate z bar x minus iy. Important result of the conjugate, that z bar whole bar is equal to z plus z bar is equal to twice x, real part only, z minus z bar twice iy, imaginary part only, and of course z equal to x plus iy, z bar multiplication is equal to x square plus y square is purely real. And if that z equal to x plus iy is equal to 0, then implies that x equal to 0, y equal to 0. If x1 plus iy1 is equal to x2 plus iy2, that means x1 equal to x2 and y1 equal to y2. Next, the sum, that the z1 plus z2 is equal to x1 plus x2 plus I y1 plus y2, and the z1 minus z2 is equal to x1 minus x2 plus I y1 minus y2, and z1 z2 equal to that x1 x2 minus y1 y2 plus I into x1 y2 plus y1 x2, and the division z1 by z2 is equal to x1 plus iy1 divided by x2 plus iy2, that is equal to, this is the real part, x1 x2 plus y1 y2 divided by x2 square plus x1 square, x2 square plus y2 square plus I into in the numerator y1 x2 minus x1 y2, in the denominator x2 square plus y2 square. Next property, that z1 plus z2 whole bar is equal to z1 bar plus z2 bar, and for minus here would be the minus sign. Next, the z1 z2 bar is equal to z1 bar z2 bar, and for divide z1 divided by z2 whole bar, that is equal to z1 bar divided by z2 bar, provided z2 bar is not equal to 0. Next, modulus of a complex number. Modulus of a complex number. That modulus of the absolute value is defined at the mod z root over of a square plus b square. And the properties of the modulus, very important. The properties are mod z equal to mod z bar is equal to minus mod z is equal to minus mod z bar. Next, z bar is equal to mod z square, mod z1 z2 is equal to mod z1 into mod z2, mod z1 divided by z2 is equal to mod z1 divided by mod z2 if mod z2, or basically you just say here the z2 not equal to 0. Next, that z1 plus z2 mod square is equal to mod z1 square mod z2 square plus 2 real part of z1 z2 bar, and for the minus here would be minus sign, sorry, a square plus b square minus 2ab, here would be the minus sign. Next one, that mod z1 plus z2 whole square plus mod z1 minus z2 square, basically the a square, a plus b whole square plus a minus b whole square, you just say that 2 into a square plus b square, or 2 into mod z1 square plus mod z2 square. This above, these below 4 are very important, that mod z1 plus z2 less than equal to mod z1 plus mod z2, and for minus, that mod z1 minus z2 is less than equal to mod z1 plus mod z2. And next one, mod z1 minus mod z2 whole mod less than equal to mod z1 plus mod z2, and here also satisfied that the mod z1 minus z2 greater equal to mod z1 minus mod z2 whole mod. Next, the geometrical representation of a complex number. Next one, that the geometrical representation. geometrical representation of a complex number. Suppose that z equal to x plus iy. So geometrical representation means the modulus of z, that r equal to mod z equal to root over x square plus y square, and the amplitude or argument, this is the modulus, and the amplitude or the argument, that the theta tan inverse y by x, this is in the first quadrant also, this is the argument or the amplitude. And next, the arc z is equal to tan inverse y by x, this is x greater than 0, the first quadrant. Next, tan inverse y by x plus pi, here x less than 0 and y greater equal to 0, this is in the second quadrant. Tan inverse y by x minus pi for x less than 0, y less than 0, this is for the third quadrant. And for the fourth quadrant, that the minus tan inverse mod y by x for x greater 0, y less 0, this is the fourth quadrant. Next one, the polar form of a complex number. The polar form, basically this is the origin and the x, the y. This is a point, let's say AB. This is r, this is the theta, and this is a and the b. So polar form, that z equal to r cos theta plus I sin theta, this is the polar form, and the r equal to mod z, and here the theta is equal to arc z, basically the argument or the amplitude of the z. Next, polar form of a complex number. Polar form for very important result, plus minus 1 and the I. So for 1, we just write here the cos 0 plus I sin 0, and for minus 1, that the cos pi plus I sin pi, and the I, for the I, that cos pi by 2 I sin pi by 2, and for the minus I, that is equal to cos pi by 2 minus I sin pi by 2. Important result involving argument, the property, basically the argument of z bar is equal to minus argument of z. Argument of z1 z2 is equal to argument of z1 plus argument of z2 plus 2k pi, even multiple of pi. Argument of z1 z2 bar is equal to argument of z1 minus argument of z2, and the last one, argument of z1 by z2 is equal to argument of z1 minus argument of z2. Next, the geometrical representation, that the sum of complex number, basically we just discuss in a previous that the z1 plus z2 sum of complex number, that x1 plus x2 plus I y1 plus y2, and the difference that z1 minus z2, here minus, here minus, and the product z1 z2. So z1 z2 would be r1 r2 cos theta 1 plus theta 2 I sin theta 1 plus theta 2, and for the quotient, this is the first one, the sum and the difference, sum and the difference, this is the product, and last one the quotient, means the divide z1 by z2, that r1 by r2 cosine of theta 1 minus theta 2 plus I sin theta 1 minus theta 2. This is the quotient. So next, that the de Moivre's theorem. So first one in the de Moivre's theorem, that the Euler formula, basically the exponential of I theta, that is written cis theta is equal to cos theta plus I sin theta. Geometrical interpretation of multiplying a complex number by exponential I alpha, that we just note z equal to r into cos theta plus I sin theta, that is written in the form r exponential I theta. So we just multiply here exponential I alpha, that would be become r exponential I theta into exponential I alpha is equal to r exponential I common here theta plus alpha. Next, the de Moivre's theorem, very important, that de Moivre's theorem for integral index cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta, when, so these are the another form, that cos theta minus I sin theta, here would be the minus. Suppose that the cos alpha plus I sin alpha to the power minus n, so here would be cos n alpha minus I sin n alpha. Next one, here the minus, here would be the plus. Next one, de Moivre's theorem for rational index. This is for the integral index. Next, for the rational index, basically rational number p by q in the form of, so that cos theta plus I sin theta to the power p by q, where p and the q belongs to I and the q not equal to 0, and the HCF of PQ is equal to 1 is given by the cos P twice r pi plus theta even multiple of r divided by q plus I sin p into twice r pi plus theta by q This is the form for the rational index where the r equal to 0, 1 dot dot q minus 1. Next, the nth root of unity. At the nth root of unity, nth root of unity says that z to the power n equal to 1. So z would be the cos 2k pi by n plus I sin twice k pi divided by n, where k 0 to n minus 1. Note that omega cos twice k pi by n plus I sin twice k pi by n. So we can write the nth root of unity as 1 omega square dot dot omega to the power n minus 1, and sum of root of unity is 0, that the 1 plus omega square plus dot dot plus omega to the power n minus 1, the summation would be 0, and also the 1 by x minus 1 plus 1 by x minus omega plus 1 by x minus omega to the power n minus 1, that would be n x to the power n minus 1 divided by x to the power n minus 1. Next, the cube root of unity. Cube root of unity means this is the special form of nth root of unity, that omega is equal to cos twice pi by 3. Just put this value n equal to 3 and I sin twice pi by 3. So here the solution, this would be the minus 1 plus root 3 I by 2, and the another solution, the omega square, would be minus 1 minus root 3 I by 2. So results involving the cube root of unity, that these are the important result, that the omega cube equal to 1 and 1 plus omega square is equal to 0, and the x cube minus 1 is equal to written as x minus 1 into x minus omega into x minus omega square, and omega and the omega square are the root of the equation x square plus x plus 1 equal to 0. Next one, the a cube minus b cube is written as the a minus b into a minus b omega into a minus b omega square. Next, next that nth root of a complex number. Nth root of a complex number means z equal to r cos theta plus I sin theta. So here z to the power y 1 by n, that r to the power y 1 by n cosine of theta plus, this is very important for JEE Advanced, 2k pi by n plus I sin theta plus twice k pi divided by n, this, and this is equal to z naught omega to the power k. Next one is very important, use of de Moivre's theorem in some expansion, that the cos n theta is written as just binomial expansion, cos to the power n theta minus nc2 cosine of n minus 2 theta sin square theta plus nc4 cos to the power n minus 4 theta and the sine to the power 4 theta. You just do for the sine n theta as well. Next, the tan n theta, you just divide the sine n theta and the cosine of n theta, and you would get the value here. Just put this value, that this nc1 tan theta minus nc3 tan cube theta plus dot dot, and 1 minus nc2 tan square theta plus nc4 tan to the power 4 theta minus dot dot. And I just do here for the series. You just know here that the series of sine alpha is equal to alpha minus basically the Taylor expansion c factorial alpha to the power 5 by 5 factorial minus dot 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 infinite series, infinite series. And next one, the cos alpha, that is the 1 minus alpha square minus by 2 factorial plus alpha to the power 4 by 4 factorial minus dot 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 and infinity. And last one, the tan alpha, that is equal to alpha plus alpha cube by 3 plus 2 alpha to the power 5 by 15 plus dot 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 at the infinity. So this is the infinite series just written as the Taylor form, and you just know one thing, that for the alpha tends to 0, we just write here the sine alpha tends to alpha and the cos alpha tends to 1. So here the higher order term or the neglecting tends to 0, first term is the alpha, and the cos alpha higher order term is the neglect and the first term would be 1. So this is the concept. We just assume the sine alpha tends to alpha, cos alpha tends to 1. This is the actual mechanism of this writing. And we just cover here the chapter summary, and we just go through our problem discussion session. First problem is coming from the recent question JEE Main 2024. It says that let z be a complex number such that mod z plus 2 equal to 1, imaginary part of z plus 1 by z plus 2 is equal to 1 by 5. You should find the value of the modulus of the real number of the mod of the z plus 2 is what? Very important questions coming from the recent JEE Main 2024. So let us assume the z equal to x plus iy. So you just given that the imaginary part of z plus 1 divided by z plus 2 equal to 1 by 5. So just put this value, the imaginary part of x plus 1, just put this value plus iy divided by x plus 2 plus iy, that is equal to what? 1 by 5. So you just do here that imaginary part of x plus 1 plus y multiply with x plus 2 minus iy. This is the third, this is the 1 by 5. Here the x plus 2 plus iy with the multiply of x plus 2 minus iy. So after multiplication, here would be y into x plus 1 divided by x plus 2 whole square plus y square, that would be 1 by 5. And here given the mod of z plus 2 equal to 1. So this would be the x plus 2 whole square plus y square equal to 1. Just calculate y into x plus 2 minus y into x plus 1, that would be 1 by 5. So after simplification you would get y equal to 1 by 5. So now that the x plus 2 whole square from this equation 1, x plus 2 whole square plus y square equal to 1. So or x plus 2 square is equal to 1 minus 1 by 25. Just put this value. Here would be 24 by 25. So x plus 2 would be what? 2 root 6 by 5, this value. And you have to find the real part of z plus 2 modulus. So here by the property of the modulus, this would be the z bar plus 2 and here would be the x plus 2. So the real part of the z plus 2 bar is would be what? 2 root 6 by 5. This 2 root 6 by 5 would be our answer, B. Next problem coming in JEE Main 2023, also recent type of questions. Let PQ belongs to R and 1 minus root 3i to the power 200 equal to 2 to the power 199 into P minus P plus 1 by Q. Then P plus Q square and P minus Q plus Q square are the root of the what equation? Very important question. Combination of the complex number and the quadratic equation of the theory of equation we just discussed in your next chapter. So this is the combination type of questions. So first of all, the given equation that the 1 minus root 3i to the power 200 is equal to 2 to the power 199 p plus iq. So next just solve here that 2 half minus I we just write in tricks to the power 200 is equal to 2 to the power 199 p plus iq. Next here would be what? 2 to the power 200 divided by 2 to the power 199, just common here, and here cos pi by 3, just apply here cos pi by 3 minus I sin pi by 3 to the power what? 200, that is equal to p plus iq. So next this would be what? 2 cos 200 pi by 3 plus I sin minus 200 pi by 3 would be what? P plus I. So this would be what? 2 into minus of minus I root 3 by 2, this would be p plus iq. So just solve here, you would get that the minus 1 minus root 3i would be what? P plus iq. So p would be what? Minus 1 and the q would be what? Minus root 3. So let the x1 be the root such that p plus q square. Just calculate this result. Minus 1, this p plus q square is x1, this is the x2, minus 1 plus minus root 3 plus minus root 3 whole square. This would be what? 2 minus root 3. And the x2 would be next one, that the p minus q plus q square. You just solve this equation. This is the equation number 1 I just write, and after do this. Just put this value minus 1 minus root 3 plus minus root 3 whole square. This would be what? 2 plus root 3. Next, the summation of two root x1 plus x2 would be what? Equal to 4, and the multiplication of the two root is the 1. So the equation would be x square minus summation of two root into x plus multiplication of two root is equal to 0. So next x square minus 4x plus 1 would be 0. This would be the answer. X square minus 4x plus 1 would be 0. A would be our answer. X square minus 4x plus 1 would be 0. Next problem, that JEE Advanced 2016 says that for an integer k, let alpha k cos k pi by 7 plus I sin k pi by 7, I be the imaginary number. You have to find the expression sum k1 to 12 modulus of alpha k plus 1 minus alpha k divided by k1 to 3 alpha 4k minus 1 minus alpha 4k minus 2. So that define alpha k is given that cosine of k pi by 7 plus I sin k pi by 7. So this would be what? The cos of, we just write twice k pi by 14 plus I sin twice k pi by 14. So alpha k are the vertex of the regular polygon having 14 sides, that alpha k are the vertex of a polygon of side what? 14. You just know this theory. So let the side length of regular polygon be what? Modulus of alpha k plus 1 minus alpha k. This is the length of a side of the polygon. Length of a side of the regular polygon. We just consider, because here the alpha k, this type of polygon we just consider here. This is the nth. So the alpha of 4k minus 1 minus alpha 4k minus 2, this would be the length of a side of the polygon. Length of a side of the regular polygon. So you have to find this value with the numerator k1 to 12, that modulus of alpha k plus 1 minus alpha k divided by k1 to 3, that alpha 4k minus 1 minus alpha 4k minus 2. This would be what? So 1 to 12 means 12 of side A. This is the side. Next 1 to 3 means 3 side of A. So you have to find 4. This is the NEET type of question, numerical answer type. You have to write the answer 4 here. Next, JEE Main 2022. If z not equal to 0 be a complex number such that modulus of z minus 1 by z equal to 2, then you have to find the maximum value of the z. Very important question. We have the property of the modulus that modulus of z1 minus mod z2 whole mod, that less than equal to mod of z1 minus z2. We use here this property, and z1 here z and z2 here 1 by z. So just put this mod z minus 1 by mod z whole mod less than equal to z minus 1 by z, or mod z minus 1 by mod z whole mod less than equal to 2. So let For our simple calculation, mod z would be t. So t minus 1 by t mod less than equal to 2, or t square minus 1 mod less than equal to 2 mod t, or t to the power 4 minus 2t square plus 1 less than equal to 4t square. You just solve here and get, this is the quadratic equation, that the t square minus 3 whole square minus 2 root 2 whole square less than equal to 0. So you have to find the two value. Two value means what? First one, the t square minus 3 belongs to minus 2 root 2 1 and 2 root 2 1 another. Next one, the t square belongs to what? 3 minus 2 root 2 and the 3 plus 2 root 2. Next one, the t square belongs to what? That root 2 minus 1 whole square and the root 2 plus 1 whole square. These are the value of the t. So maximum value of the mod z would be what? Root 2 plus 1. Among this value, the maximum value would be what? Root 2 plus 1. This is basically t, and you have to whole square and you have to find the t. This is the root 2 plus minus 1, and root 2 plus 1 will be the maximum value. D would be our correct answer. Go ahead. Our last problem, recent questions coming in JEE Main 2024, just recent question. This is also a NEET type of question. You have to find the numerical value. If alpha denotes the number of solution of modulus of 1 minus I to the power x equal to 2 to the power x, and the beta is equal to mod z by arg z, where z equal to pi by 4 into 1 plus I to the power alpha 1 plus I to the power 4 into 1 minus root pi I by root pi plus 1 root pi plus I plus root pi minus I divided by 1 plus root pi I. Then the distance of the point alpha beta from this line is what? So this is simple problem, but in complex written. You have to find the distance of the point alpha beta from the line. Let's see. This is origin x and the y. Let us assume this is the line. This 4x minus 3y equal to 7. And you have to find the distance of the line from this point. Suppose this is a line, straight line, this distance. This is the alpha beta. And after you just find here first alpha beta point. And after getting alpha beta point, you just know the distance d from a point to a straight line. Suppose x plus by equal to 0. This is the coordinate geometry of the straight line from class 11. We just discuss in after next 2 or 3 more class. So here the equation given, the modulus of I minus 1 minus I to the power x equal to 2 to the power x. This is the equation. So this would be what? Root 2 to the power x equal to 2 to the power x, or 2 to the power x by 2 would be what? 2 to the power x, or x would be 0. So number of solution for number of solution alpha equal to 1, x equal to 0 means alpha equal to 1, number of solution, and z is given. This is the tricks. Z is given what? Pi by 4, 1 plus I to the power 4 into 1 minus root pi I divided by root pi plus I plus root pi minus I 1 plus root pi I. This is z. So you have to solve this first. Pi by 4, 1 plus I to the power 4. This would be what? 1 plus, just multiply with the negative 1 and you just get that the 1 plus pi plus 1, and in the denominator root pi plus I into 1 plus root pi I. So this would be what? Just solve this. Pi by 4, just multiply, and I just here apply the formula of 1 plus a plus b to the power 4, a plus b to the power n, suppose n equal to 4 here. So 1 plus 4i plus 6i square plus 4i cube plus 1. Here this would be what? 2 plus 2i pi divided by pi plus 1, and pi by 2 is common here. In the numerator 1 plus 4i minus 6 minus 4i plus, just calculate this, multiply and the calculate. Just simple this step, just multiply and calculate, you would get this result, this expression. And after solving, this would be what? This would be pi by 2 into minus 4 divided by I. So this would be what? Minus 4 means 4i square. So I just write here 4i square. So 2i pi I. So z, our z would become 2i pi I. So beta given the mod z by arg z. Mod z by arg z. So mod z means what? 2i pi. Arg z means what? The pi by 2. Arg z pi by 2. Because this cos theta plus I sin theta. Euler theorem. E to the power I theta. Cos theta plus I sin theta. Just put this value. So here beta would be what? Pi cancel, 2 into 2 4. Beta 4. And we just get the alpha means here, that's denote, alpha denote the number of solution of this equation. So alpha is 1, this beta 4. So alpha beta here, this is the 1 4, and we now find the coordinate of alpha beta 1 4, and after you have to find, this is the line that the 4x minus 3y equal to 7, and the point here the 1 4, this distance you just do in your straight line. I just write here d equal to what? That modulus of 4 minus 12 minus 7 divided by 5 equal to 3. I just write here because I just do in use some one thing. Suppose this is a straight line, x plus by plus cz equal to d. Suppose a point x1 y1 z1. So d distance would be what? Just put this coordinate here, x1 by1 cz1 divide by root over of this coefficient x square y square z square unit. This is the distance. I just apply here, and I just learn you in a straight line class. So we just cover here the chapter summary and the problem, 5 important problem coming in JEE Main Advanced. For your simplicity and the practice and more learning, I just usually give you another 5 important questions. You just pause this video and take a screenshot quickly. I think you just take a screenshot of this 5 problem and we just cover here 10 important question coming in JEE Main and Advanced Mathematics Complex Number chapter. So I think after solving this 10 question, you just go through all the questions of this chapter and you just do solve the more questions from this chapter you just by yourself. So last the contrast section, solve this homework, and if anyone needs this file of my YouTube lecture, just mail without no hesitation with this ID catshottingers1935@gmail.com. Thank you very much. Stay well and happy. Have a good day.